Hey guys, how's everything going? This is JSer. In this video, I'm going to solve number 869 reordered power of 2 from LeetCode. Let's take a look. Starting with the positive integer n, we reorder the digits in any order, including the original order. So it's actually technically all the permutation, right? Such that the leading digit is not 0. Okay. Return true if and only if we could do this in a way such that the result number is power of 2. So 1 is power of 2, right? To the 0, so it's true. 10, it's not. It's 2 times 5. 16 is power of 2. 24, positive 2. No, it's not power of 2, so false. 46, we could reorder it with 64, true. The number is from 1 to 10 to the power of 9. So actually, this is a pretty small number. Okay, so the brute force of this problem is actually we just follow the description. We reorder the digits in any order. So actually we get the permutation and check if it is a power of 2, right? Power of 2. To get all the permutations, obviously for the nth of n, we actually have n a lot of permutations, and for each permutations we should check if it is power of 2. How to check if it is power by 2? We could just divide, right? Divide all of them. Divide the 2 and 1 by 1. Actually, the number here, nth of 2, so how, we log 2 n, right? If divided to maximum, it's log 2 n times. So this is the time complexity of this approach. How could you prove it? First, we could actually notice that the number is relatively small. Rather than when we get a permutation and compare it, we could actually list up all the possible the power of 2 and just to check if the number is in it or not, right? First we get all the power of 2 within this range. Okay, so this is powers, like say powers. We will finally use the set, so we create a new set. Constant max as described here. Max is 10 to the power of 9. And even if after reordering, it won't pass this max, because for the max number, right lead 10 digits, it's actually only 1, 0, 0. So the maximum, without it, the maximum would be 99 or 9 with 9 digit, right? So this is the maximum, no problem. And we for let I is 0, this will be the power of 2. We just increment it, so, and put it into powers. So if to avoid unnecessary calculation, I will use the base. It equals to 2 to the power of 1. Okay. So 0 and 1. Yeah, we would times for 0 times. Okay. Let we should put this actually while base is smaller than max. If it is smaller than the max, we put the powers we would put in it, right? While inputting it, we put it into a string. Well, first we put in the numbers. We add a base, and base would times with 2. And this is 1. We push it, and then we get 2. Yeah, and we now get the let's see what the numbers are. Set is not defined. Oh, powers. I'm sorry. Yeah, this is all numbers actually, not that much, right? And we need to compare the digits against these numbers, so we better to normalize it. Let's create a function called here normalize, which is string, which is pretty simple. We just split all the digits and sort and join. Now we could normalize for, we add, we will normalize it to a string, and then we'll push it into the set, right? And finally, in this main function, if we check the n is part of 2, we just first normalize it and check if it is in the set or not. So we just return the powers has normalize n to string. So this is it. Normalize base. Oh, not base. I'm sorry. It should be n. Missing. Oh, here. Yeah, submit. Cool. So this is it. This is our solution. It's pretty fast, I would say. Yeah. So that's it. Hope it helps. Or rather than we sort, we would change this into another set. We don't need to sort again. And while we're comparing the power has, oh, we no. This is necessary. Yeah. Okay, that's all for this problem. Hope it helps. See you next time. Bye bye.